Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to continue on chapter 1, still on the method of transformation. So for this topic is method of transformation. We're going to focus on two continuous random variable. So theorem number 4, let's look at theorem number 4. Right, this is theorem number 4. Let fx x1 x2 is the joint probability density function. So this is we are talking two continuous random variable, which is joint probability distribution function or bivariate distribution function for continuous variable. So at random variable x1 and x2, x a random variable x1 and x2. So if the function given by y equal to u1 until u1 is x1 and x2, and another function is y2, u2, and contain x1 and x2. So this is another two random variable, two new random variable, right? Ada dua random variable yang baru, partially differentiable, which is we can get a marginal PDF. So I hope you know how to get a marginal PDF. With respect to both x1 and x2, represent the one-to-one transformation for all value within range x1 and x2. Then dia kata kat sini, this is the point yang dia nak sebut. Then this value x1 and x2, the equation of y1 and y2 can be uniquely solved, right? Meaning we can determine their inverse solution, right? To give x1 equal to w1 and x2 equal to w2. Remember last topic, which is in one continuous random variable, right? So we have y equal to w y1 as x equal to wy, right? X equal to wy. So now we have two x1 and x2. So we're going to have w1y, y1, y2, and x2 should be equal to w2, y1, y2. So we have two functions, right? For the corresponding or density function, a density of y1 and y2, the joint density function of y1 and y2 is given by this is the function f w1 and w2. This is a joint probability distribution for w1 and w2 multiplied with the j, determinant of j. So this is a difference between absolute j yang kita tengok sebelum ni. And for the first for one continuous random variable, we are talking about absolute value. Now we are talking about J, the J matrix, right? The determinant of J matrix. So J means that the Jacobian matrix. So this is a J lah. J is a Jacobian matrix. So kejap. I need to change this to thicker one. Right? So we are talking about the Jacobian matrix. So J is called as Jacobian transformation. Is the determinant of the first whole variable with respect to the first new variable, right? For the first this one we call x1 lah, x1. Sorry, kita tak kata x1 lah, kita kata 1 1. This is 1 1 2 1 2. So 1 1. So 1 1 first row, first column. We're going to differentiate on the first whole variable with respect to first new variable. Right. For the second first row and second column, 1 2, we're going to differentiate the first whole variable with respect to the second new variable. Right, very simple. For the second row and first column, 2 1, we're going to differentiate the second whole variable with respect to the first new variable. Right? And the fourth one, 2, 2, which is we're going to differentiate the second old variable with with respect to the second new variable. Right, so kita nak tengok dia punya example macam mana nak pakai benda ni kan. So kalau kita ada, let's say, old variable is x and y, for example, and new variable is v and w, for example, right? So J, the Jacobian matrix, we're going to find the determinants of the differentiation of the first old variable with respect to the first new variable, right? And this one, first old variable with respect to the second new variable. So this is the first, second, right? Okay, so sama juga yang bawah ni, the second new old variable with respect to the first new variable, the second old variable with the second new variable. So we need to find the determinant lah. So how to find the determinant? So this one multiply with this one minus this one minus multiply with this one. Right? Kita ambil the concordance, right? So now let's look at example number 19, so we can see the real example to solve and apply the Jacobian matrix and how to use transformation method to find a new joint probability function. So remember, we're still under function or random variable. The objective is we want to find a new PDF, right? For this case, we have two continuous random variable, right? So we need to find a new joint probability distribution function. So let's look at example number 19. So example number 19 says that let x1 and x2 be a continuous random variable. This is a two continuous random variable. Right, two continuous random variable, giving the joint probability density function is for x1 and x2, where x1 is range between 0 and 1, x2 is 0 and 1 jugalah. So sometimes dalam buku dia kata this is omega x1, this is omega x2. Mana-mana buku sama je dia punya definition, this is representing range. So find the joint probability density function of y1 equal to x1 minus x2 and y2 equal to x2. So first step is we need to find the inverse solution of y1 and y2. So y1 equal to x1 minus x2. So this one should be, kalau kita ambil x dululah, x1 lah, x1 equal to y1 minus x2, and we know that y2 equal to x2. So this one kita substitutekan dia, it will become y1 minus y2. Sorry, it's not minus, plus. Kita bawa ke sana jadi plus, right? Okay. So this is our first new function. So which is w1, y1, y2. Right? Tulis cantik-cantik. This is x1 equal to y1 minus y2. So it become another color, w1 y1 y2, right? And we know that x2 is equal to y2, so this one become w2 y1 y2. Right, remember the theorem number 4 says that if you want to find a new function, right, So this is the formula, right? So we're going to find the function of join W1 and W2 and multiply with the determinant of Jacobians. So second step is, so before we go to the second step, kita tulis dulu dia punya function G Y1 and Y2 is equal to F, right? So this is the first one, W1, Y1, Y2, and W2, Y1, Y2, right? And multiply with the Jacobian matrix, the determinant of Jacobian matrix. So this is the formula. So let's solve for the Jacobian matrix first so we can move forward. So number 2, so the Jacobian matrix, it should be dx divided by dx1, right? So because we have x1 and x2 divided by y1, right? dx1 with respect to dy2, right? First old variable divided by the first with respect to first new variable. We want to differentiate the first old variable with respect to the second new variable, right? Remember, itu senang. Right. Second row, we want to differentiate the second new variable, second old variable with respect to first old variable. Right. Second old variable with respect to second new variable. Right, boleh nampak? So then the first one going to be, this is our first new variable, first variable, second variable, right? First old variable, so d with respect to first new variable, dy1, y1, y1 minus y2. Yes, Muhammad Faiz. Any question? I see, yeah, y1 plus y2. Okay. Terus tadi I padam kan? Okay, alright. Thank you. This is plus y2. So dex first old variable with respect to second new variable. Right, new variable y1 plus y2. This is our first old variable kan? Senang nak ingat this is first old variable. This is a second old variable. Right? Yang di dalam ni adalah new variable lah. Okay, next, second row, second new old variable y2 with respect to first new variable. Second old variable with respect to second new variable. Right? Okay. So then we need to find the determinant. Before we find the determinant, we need to differentiate first. So this one with respect to y1 should be equal to 1. This one with respect to y2 should be equal to 1 as well. This one with respect to y1 should be equal to 0. This one with respect to y2 equal to 1. Right? Boleh faham? Very simple, right? So next, to find the determinant, so to find the determinant, we need to multiply the first one. This one should be here. On the right hand side. Dia pergi turun ke kanan, turun ke kanan dulu. So from left to right. So this one, it should be 1 multiplied with 1, right? 1 multiplied with 1, and minus, right? Minus. On the left to right, right to left. Left to right, right to left, to find the determinant. So next, 0 and 1, right? So this one 1 multiply with 0. Boleh left to right, right to left. Senang ingat macam tu. So this one should be equal to 1 only. So this is the determinant of J. Step number 3. Now we're going to copy this one. The formula, I tulis balik lah, senang. So G, Y1, Y2 should be equal to F, W1, Y1, Y2 and W2, Y1, Y2. Right? And multiply with the determinant of J. So this one, kita tengok balik dia punya PDF of the original one for X1 and X2. I remember the original PDF for X1, X2, right? We're going to replace the value of X1 and X2 to become our new PDF. So this one should be 4. X1 is equal to Y1 minus plus Y2, right? And X2 is equal to Y2 multiply with determinant of J. So nanti kita masukkan J tu tapi sama dengan 1 kan. So sama dengan 1 kita multiply with 1 only lah. Tak payah pening-pening kepala. Right. So this one should be equal to kalau you multiply kan, so you become 4y1 y2 plus 4y2 squared. It become sama je lah, kalau kita nak keluarkan pun boleh juga, don't worry. So kita keluarkan lah 4 ni, constant kita tak keluar lah, y1 y2 plus y2 squared, right? So this is our new joint probability function. And for domain, we know that x1 having range from 0 to 1. So x1 is equal to y1 plus y2 1 0, right? So this one, let's say kita letak y1 saja, y1. So this one should be 1 minus y2 and this is going to be y2, negative y2, right? And then another function is given by 0 x2 until 0 until 1, right? And we know that y2 is equal to x2, right? Boleh? So since x2 is equal to y2, dia dalam bentuk ni kan, bentuk ni okey, kita biar macam ni je lah. So G y1 y2 should be equal to let me use another color to represent the new PDF. y1 y2 should be equal to 4 y1 y2 plus y2 squared, and then this is a 0 elsewhere. The range for this one should be negative y2 y1 1 minus y2, and this one should be from 0 y2 and 1. So this is our new PDF. Kita biar macam tu saja, right? Okay. I think tomorrow right. So okay, are there any questions so far? Alright. So if you don't have question, then move to the next example. Example number 20. Yes. variation, bukan all variation, all variable. So all variable ni lah. W1 ni is a function of all variable lah. This is all variable. Tapi yang the new variable yang kita nak determine adalah y1 and y2. Right? Boleh faham? Right, so this is x1 is a old variable lah. So, nampak tak dekat atas ni we are talking about x1 and x2, dia punya original kan? Original, this is a old variable. So when we find the inverse function, so we're going to get x1 and x2 equation. So x1 and x2 equation ni dipanggil old variable lah. So the new variable is y1 and y2. So we are looking into y1 and y2. Right? Boleh eh? So, tak apa, kita tengok yang satu lagi. Alright. Okay. This is quite long solution jugalah. This one. Let me tarik siap-siap. Alright. So, example number 20. x1 and x2 be a two continuous random variable having a joint probability density function where fx1 has 2. So, kita ada 2, 1 minus x1. Where x1 is between 0 and 1, x2 is 0 and 1 juga. Right? So, dalam ni missing x1. Tapi tak apalah. Dia ada bagi range dekat sini. We know that this is a joint probability distribution function. And we want to find the probability distribution function of y2 is equal to x1 and x2. So, dia tak bagi juga x1. Kalau dia tak bagi x1, it's supposed to give x1 lah. Y1 lah. Y1. So, I think kita create satu lah bagi complete the equation. Y1 is equal to x1. And for the sake of example sepatutnya dia akan bagilah. Right? So, dia akan bagi. So, y1 equal to x1. So first we need to find the joint probability distribution for y1 and y2 lah. So the inverse, first step is inverse solution. Inverse solution for y1 and y2. Right, so x1 is equal to y1. Right, this is equal to w1, y1, y2. So this is the old variable lah. Ingat sebab kita ada x is a old variable, y is a new variable. So this is the first one. The second one is x2 is equal to y2 divided by x1. So it's also equal to y2 divided by y1. So this is a w2, y1, y2. Right? So now kita tahu kan this is, I ulang sekali lagi in case you don't understand. Y1 and y2 is our new variable. Right? This equation, this is our old variable. Sebab apa? Sebab density function, the original density function is x1 and x2. Right? So now, the next one, we want to find the Jacobian matrix. Jacobian determinant or Jacobian matrix. So this one should be the old variable with respect to new variable. The old variable, the first old variable with respect to the second new variable. The second old variable, the second old variable x2 with respect to the first new variable, the second old variable with respect to new variable. Right? So now we input the value dalam tu d, the first d with respect to dy1, this is y1. With respect to dy2, this is only y1. With respect to dy1, this is only y2 over y1. with respect to dy2, this is y2 over y1. Okay, so this one should be equal to 1, this one should be equal to 0, this one with respect to y1. So kita bawa atas turun bawah balik ya, jadi negative y2 over y1 squared, right? And this one should be with respect to y1 y2, it should be equal to 1 over y1 lah. Boleh, right? So now we want to find the determinant. So the determinant should be left, right, right, left, right? So this one 1 multiply with 1 over y1 minus 0 multiply with negative y2 over y1. So this one should be only y1. 1 over y1 lah. Right? So the next step is we're going to find the function of new random variable, which is f w1, y1, y2, and w2, y1, y2, right? And multiply with the Jacobian's matrix. So the original PDF is 2 minus 1 minus x1. So kita tulis kat sini supaya kita tak terlupa. So the old one is 2, 1 minus x1. So this is the old one. So we're going to input the x1 kat sini. So this one should be 2, 1 minus x1 is equal to apa? Kita tengok kat atas, x1 is equal to y1, right? Is equal to y1, right? And multiply with the determinant of Jacobian 1 over y1. So this one should be macam mana simplify this one? This is y1 kan? Tak payah simplify teruk-teruk. 2 1 minus y1 over y1 lah, senang. Senang kita biar macam ni lah. Right. So next we already find the new distribution function. Muhammad Faiz, yes. Right. This one. Ni kita dah kita dah masukkan dalam ni. So dalam original function we only have y1, x1. Right, we don't have x2. So only contain x1 lah. Right? Okay, so you need to find the domain for. So given x1 is from 0 to 1, so kita tulis saja. X2 pun sama juga. X2 is 0 to 1. So x1, so agar kita tak lupa kan, x2, x1. So this one should be x1 is equal to y1, right? x2 is equal to y2 over y1. Remember kita punya equation tadi? Right? x1 is equal to y1, x2 is equal to y2 divided by y1. So x1 is equal to, this is a y1 from 0 to 1. And x2 is y2 over y1, right? So this is from 0, y2, y1, right? So nampak tak sini, this is continuous, this is pun continuous juga lah. So ni tak ada, ni straightforward lah compared to the first example. Nampak susah sikit nak solve kan, kita biarkan macam tu. But this one kita boleh simplify, but it's straightforward. So this one should be y2, y1, 1, right? Bila kita combinekan dia kan, right? So this one should be equal to our new density function. Joint density function should be equal to g y1 y2. This is 2 is 2 1 minus y1 divided by y1 from 0 y2 y1 until 1. This is 0 elsewhere. Right, this is a new PDF, joint PDF function. Right? So tadi tanya mana pergi y2, mana pergi y2. Okay, now let's try to find the PDF of y2. So how to find the PDF of y2? Means that we want to find the marginal probability distribution function for y2. So let's try to find this marginal PDF of y2. Can you find it? Can you find it? So how to find marginal PDF? So we know that the distribution function y2 1 minus y1 divided by y1, the range is from y0 y2 y1 1, right? So to find the PDF of marginal PDF of y2, so f y2 should be equal to from with respect to y1 kan, with respect to y1, this one from y2 until 1, and then this is 2 1 minus y1 divided by y1 with respect to y1. So this one should be equal to, you solve for this one, 2 y2 minus ln y2 minus 1. Right, so this is the range of 0, y2 and 1 lah. You solve this one. Right. Okay, dah. Kita move to the next example. Okay. Right, kita move to the next example, which is example number 21. 21, I have 21, 22, 23, 24, 25. 21 is a long example. Okay. But it's okay lah, boleh lah kita tengok 21 betul, then kita skip 22, 23 also skip, 24 skip, or we focus on 25, right? Sebab 22 and 22, 23, 25, 24 ni simple saja, very simple, right? Straightforward. 25 kita ada dua PDF, tengok macam mana nak solve tu PDF ni. Okay, no worries. Look at example number 21. Or you want to solve by yourself? You want to solve by yourself or you want me to show? This one is quite simple, sama juga step dia dengan example number 20 and 19. Right? You want me to show or you want to do by yourself? Huh? Hey students, you want me to show? Um, okay, boleh, boleh, boleh. But okay lah, I show lah. Ha? I takut tak cukup masa kan? Kita start lambat. Alright. Okay, example number 21. So we have the joint PDF of x1 and x2. So exponential negative x1 plus x2, where x1 and x2 is more than 0. Right? You want to find the PDF of y1 equal to x1 plus x2, and y2 is equal to x1 divided by x1 plus x2. This is complicated. Right, so first step to find the inverse function kan? Find the inverse solution. Right, so inverse solution x1 should be equal to this one should be, I letaklah answer dia kan. So this one should be y1 and y2. X2 should be equal to y2, 1 minus y2. So how to get this? Right, so kita tengok y1 equal to x1 plus x2, right? So let's say x1 is equal to y1 minus x2, right? So this is going to be our first. So the second one is y2 is equal to x1 divided by x1 plus x2. Right? Basically kalau kita ganti-ganti pun boleh juga kan. So y1 this is y2 is equal to y1 kita masuk dalam ni x1 divided by y1, right? And then x1 dekat sini adalah y1 minus x2. This is y1 minus x2. So x2 is equal to, this is x2, right? Okay, kejap, I confuse sikit. Wait. X2 kita tak dapat lagi kan? Where is x2? Tak dapat lagi Kalau kita nak, kita kena boleh juga ganti kat sini. X2 is equal to y1 minus x1. So x1 kita complicated balik lah. So let's try the longest way. Senang kita nak faham kan. This one should be, daripada sini kita work out y1 kita letak x1 plus x2 dekat atas lah. Senang kita nak tengok. So this one should be x1 divided by y2 equal to x1 plus x2, right? Boleh? Boleh dapat? Macam mana I transform this one to this one? So x1 is equal to y1 minus x2 divided by y2. This one equal to x1 plus x2, which is also equal to y2. Kejap. Nampak complicated dah. This is y1 kan? y1. Jangan salah notation. This one should be y1. So now our new equation here is y1 minus x2 divided by y2 equal to y1. So y1 minus x2 equal to y1 y2. So next is we know that this one should be equal to second equation lah. Kita letak second equation dulu. Nanti kita lupa kan. Right, kita stop kat sini. So from from this, right? Kejap fokus kat sini dulu. Right, from this, okay, kita tengok dari sini. From this y1 equal to x1 plus x2. Right, kita masukkan dia dalam masukkan dia dalam 2. Masukkan dalam 2. So 2 adalah y1 x1 plus x2 minus x2 equal to y1 y2. Right? So then ini boleh mati, itu tinggal x1 equal to y1 y2. So we have a new variable, kan? Right? Okay, solve for x1. Right? So how about x2? So now let's look at sama juga lah, kita tengok dari sini juga. Sini nampak senang, kan? y1 equal to x1 plus x2, right? So di sini ada y1, ni ada x1, kita boleh ganti-ganti sajalah. So x2 kat sini should be equal to y1 minus x2, right? X1, kan? Okay, tulis cantik-cantik. So x1 is equal to y1 minus y2, y1 multiply y2. So x2 is equal to y1 minus y1 y2. It's also equal to y1 1 minus y2, right? So we have two variable, right? So that's why is equal to benda yang sama lah. X1 is equal to y1 y2, x2 is equal to y1. It's supposed to be y1 dekat sini. Y1 1 minus y2, right? Okay. And right, so we already have the equation. So this is going to be our w1 y1 y2. This is going to be our w2 y1 y2, right? So next we're going to find the Jacobian's determinants matrix. So d x1 with respect to y1, d x1 with respect to y2, d x2 with respect to y1, d x2 with respect to y2, right? So this one should be d dy1, right? I tukar color, so I tulis kat sini lah. Y1 y2, right? d y2, right? So this one should be y1 y2, right? d with respect to y1, so this one should be y1 1 minus y2, right? And with respect to y2, so this one should be y1 1 minus y2, right? Boleh? Right? Boleh, Okay, so solve it. So this one should be with respect to y1, kita tinggal y2. With respect to y2, kita tinggal y1. Then with respect to y1, kita akan tinggal 1 minus y2. With respect to y2, so kita akan tinggal lain-lain ni semua tak ada lah. Tinggal y1, negative y1. Right, so this one left right, right left. Jangan lupa left right, y2 multiply with negative y1 minus right left, y1 multiply with 1 minus y2. Right, so it should be equal to negative y1 y2 minus y1 plus y1 y2, right, is equal to negative y1. Okay, so the next step, this is step number 1, this is step number 1, this is step number 2, step number 3. Step number 3, we want to find the new joint probability distribution, which is y1 y2, right, is equal to f w1 y1 y2, right, w2 y1 y2. Oops. Whereas we multiply with the Jacobian of the matrix, the determinant of Jacobian matrix. So this one should be, the original function is exponential x1 plus x2. So exponential negative x1 plus x2, is it? Yep. So x1 is equal to x1 is equal to y1 y2, x2 is equal to y1 1 minus y2, right? Okay, so we just input the function, the value dalam function ni lah. So it should be equal to, kejap nak guna color lain lah. Color apa yang best? More colors. Think pink also good lah. Pink terang, pink cerah. Cerah sangat tak syok. Gerak sikit lah. Okay, we use a pink color, right? So this one should be exponential negative y1, y1, y2, right? We input the x block, y1, kita tulis elok-elok lah, cantik sikit. This one should be y1 minus y1, y2, right? Okay, boleh? So let's solve this problem. Multiply with j, right? So this one should be equal to, kalau kita masukkan dalam ni, kita negative, so kita akan tinggal exponential negative y1 multiply with the j is negative y1. So we are taking the absolute kan, sini, right? Absolute j, determinant j, so should be y1 exponential negative y1. Yeah. Okay, so next we need to find the domain. Number 4, domain. So for the domain, this one is from 0 to infinity, right? So 0 to infinity, which is x1. X1 is 0 to infinity. So y1, kita tengok x1 is from 0 to 0 to infinity, right? So y1, kita tahu x1 is equal to berapa? y1, y2, right? So kita input y1, y2, infinity, 0, right? So it's supposed to be by right, and y2, y1 from 0 to infinity jugalah. right? Kita bawa ke sana, lebih kurang sama jugalah. Let's assume dia bukan a very small number kan, right? So it's also is to infinity juga, and x2 is from 0 to what? 0 to infinity juga. So 0 to infinity. So we know that x2 is equal to tapi it's hard to find out kan, y1 1 minus y2, right? So di kat sini kan 0 to infinity juga kan. So why not kita look at, this is very hard to solve, right? So kita akan dapat y1 y2, right? Nampak tak complicated kan? We don't know how I personally don't know, find it very hard to solve lah. So let's look at when you have a very hard solution domain dekat sini, why not kita tengok the original formula, original random variable, which is x1 divided by x1 plus x2. x1 divided by x1 plus x2, right? Okay, so let's say kita kata x1 is equal to 0, y1 is also equal to 0, right? Betul? Betul? So let's say x1 is more than 0, right? Let's say x1 is more than 0. Let's say x1 is equal to 5. And x2 is also equal to 5, right? More than 0. So this one you divide by 5 divided by 10 is equal to 1 over 2. Right? Boleh faham apa saya cakap? So the combination here is hard to go to infinity. Right? So kalau kita tengok, let's say the combination dia boleh jadi equal to 1. Sebab mungkin dia x1 is equal to 2, right? And x2 equal to 0, then 2 divided by 2 is equal to 1. Right? Maybe a combination. So so we can say that the range of y2 maybe from 0 to 1 only, right? Sebab kita boleh based on agak-agak lah, masuk nilai kan. So let's say kita kata x1 and x2 equal to 0, so both going to be 0, right? Right? Sebab dia punya range dia, asal dia x must be more than 0, right? The range, the early range, right? X must be 0 or more than 0. It cannot less than 0, right? So kalau kita x more than 0, so it can be either x1 more than 0 or x2 equal to 0, right? The worst case is x1 is more than 0, x2 equal to 0. So it's going to be from 0 to 1, right? So this is going to be your new domain. So now our new domain, new function gy1 y2 is equal to mana function kita, y1 exponential negative y1. This is from 0 to infinity, 0 to 1. Right, so this is our new joint probability distribution. Okay, boleh? Right, so next example number 22. I think you can do it by yourself, right? This is a simple example, right? Sama straightforward saja, benda yang sama. Example number 23, you can also do it by yourself. But don't forget, kat sini dia tanya satu lagi soalan. Find the PDF of Y2. So you need to find the marginal PDF of Y2 lah. Right? So with respect to, we integrate with respect to Y1. So example number 24, also a simple example. Right? Simple example. Straightforward lah. Now example number 25, right? Let's look at example number 25. Nampak pelik sikit kan? Dia bagi PDF, marginal PDF of X, marginal PDF of Y. So by using the transformation techniques, find the joint PDF of Y, V equal to X minus Y. And W is equal to Y, right? So this is going to be our last question, example. Right. So now, the joint PDF of X is equal to fx is equal to 1 over delta exponential negative x over delta. Right? X is more than 0. And fy is equal to 1 over theta exponential negative x over theta. This is, if you notice that this is a exponential distribution. Okay? Both x and y having exponential distribution. So this is exponential distribution function. So we want to find the joint PDF of v minus equal to x minus y and w equal to y. Right? So first step apa? We need to find the inverse solution. So the inverse solution of v and w. So v is equal to v is equal to x minus y. So let's say we find it for x dulu. And x should be equal to v plus y. Tapi ada y dekat sini kan, tak show. So we know that w is equal to y. So we just input the value x equal to v plus w. So this is going to be our first w lah, which is kita tak pakai x, y1, y2 kan. Kat sini kita pakai vw. Tapi dah ada w kat sini, tak shock betul lah. Tak apalah kita pakai kan. Alright, so this one going to be our w2vw. You boleh change, tapi tak boleh change juga kan. Kita pakai, kita tak mau pakai w1 dan w2 lah. Kita pakai u1 and u2, macam ada original PDF. Nampak beza sikit kan. Baru dia tak nampak confused. W ada dua kali W kan. Alright, next is we're going to find the Jacobian determinants. Right, so this one should be D so dv, sorry it's not dv, dx, this is the first old variable, this is the second old variable. So dx with respect to the first new variable, dx with respect to the second new variable, dx dy, the second old variable dy with respect to the first new variable, dy with respect to the second new variable. So this one should be dv equal, not equal to, I guna color lain so kita tak confuse, v plus w, right? dw v plus w, and then next dv and this is y only, dw, and this is going to be y only. So then we're taking the determinant. So this is going to be dv is equal to 1, dw equal to 1, dv, this is not y, salah. This is going to be w lah, right? Berhati-hati sebab y is equal to w. This one pasal saya tak terbalikkan, kena terbalikkan lagi, okay, terbalikkan. Y equal to w, right? That's why I confused. That's why you kena jangan terlepas satu step pun. Make sure you letak step semua sebab you later on maybe you first time you akan rasa okay, you boleh buat lah kan. Later on bila dah banyak-banyak tu then you akan confuse, akan terhilang. Susah tulis W, macam mana tulis W? W, alright. Right, so this one should be equal to 0 and this one should be equal to 1, right? And definitely left, right, right, left equal to 1. Right, so our new PDF VW should be equal to F kita tak pakai W dah, kita pakai U1 VW U2 VW. Right, multiply with the determinant of Jacobians. So this one should be I think I nak ubah sikit lah. Sebab di sini kita pakai absolute value dekat sini. Di sini Jacobian ni sepatutnya is understood as a determinant matrix lah. Determinant kita ubah sikit. So this one should be determinant. Kita pakai the word determinant J kat situ. Right. Sepatutnya determinant J dekat sini lah. Dia punya absolute value of J kat sini lah. So kita akan buangkan this one. So kita bawa ke sini. Okay. So you understand. Dekat formula ni nanti confuse kan? Sebab kita nak pakai lagi absolute kat sini, kita buat absolute depan. Kita nak boleh juga nak letak absolute dekat depan. As long as kita solve absolute function dekat sini lah. Pun boleh jugalah. As long as you understand, mana-mana pun boleh. Nak letak dulu kan, nak letak kemudian pun boleh juga, no problem. Alright. Sebab I letak kemudian, I takut I confuse dengan first kan. I takut confuse kat sini. Takut sini I tak letak negatif. Ini negatif kalau I dapat negatif, but I lupa nak change dekat sini, I bawa ke sini. Okay. Alright. Next is going to be first function is U1. U1 is 1. Oops. Kita pakai color lain pula, color hitam. 1 over delta exponential negative x over delta. So this one x is equal to v plus w, right? X equal to v plus w. So kita replace x equal to v plus w. Nampak tak cantik I tulis I tulis cantik. Right. So it should be v plus w over delta. And multiply with 1 over theta exponential negative y over theta. So y is equal to w. Just change to w. Right. So this is the first joint probability. Right. And multiply with the absolute value of 1, right? It should be equal to 1. So now we can solve this one. Should be equal to kita bawa constant keluar lah. 1 over delta theta exponential negative v plus w over delta minus w over theta. Right. you can solve this one or even leave it like this lah. So okay, that's all. So how about domain? Domain x is more than 0, y is also more than 0 because this is exponential distribution, right? Right, exponential distribution. So now x is equal to v plus w more than 0, v equal to negative w, y is equal to w is equal w is more than 0. So this is more, kan? More. Right. So W should be on the right hand side. So kalau kita boleh combine kat sini 0 W V. And of course this one infinity lah. So our new PDF here should be G VW. It should be equal to 1 over delta theta exponential negative V plus W over delta minus W over theta. This is from 0 V infinity, 0 elsewhere. Right? So this is our new PDF. Any questions so far? So if you don't have question, I think we stop here. Next class, we will focus on moment generating function. So before we go to moment generating function next class, please revise back the theory of getting moment generating function, which is expected value. Macam mana nak integrate, nak dapatkan moment generating function, you need to integrate with the expected of tx with a PDF. Make sure you're familiar with this one. And the theorem regarding the moment generating function, I think STA 206 dah belajar ni. Belum? Sudah kan? Moment generating function, right? You already learned about the... Sudah? Right, so you already learned about all the theorems, Theorem 6 ni you belajar. Tapi never mind, you just refresh back your knowledge. We also will discuss back lah the basic theorem, kan? And then before we go to detail. Okay, I think that's all. Thank you very much. Assalamualaikum.